All right, let's kick off another deep dive. Today we're going to be exploring open educational resources,
Ooh, interesting.
but we're going to be taking a bit of a unique approach, a slightly unusual route.
Okay, I'm intrigued. Lay it on me.
So get that we're going to start with a web page all about a JavaScript HTML5 applet that simulates the volume of a tank.
Really?
I know, right?
The volume of a tank simulator.
Yep, a tank volume simulator.
Hmm.
And this fascinating little tool, it's hosted on a site called Open Educational Resources, Open Source Physics at Singapore.
Right away, that gives us a little bit more context, doesn't it? It suggests that there's a much bigger educational purpose at play here.
For sure. So let's break it down. What exactly is this volume simulator and how does it actually help students learn?
Well, from what we've got here, it seems like it's designed for primary school students
Okay.
to help them really grasp the concept of
That
volume.
makes sense.
You know, like those colorful blocks kids use to learn about shapes and spices.
Oh, yeah, for sure.
Imagine like a digital version of that. I think this simulator probably lets students play around with the dimensions of a virtual tank. And then they get to see in real time how those changes affect the volume.
So instead of just reading about volume in a textbook,
Exactly.
they get to actually experiment and visualize it.
Yeah,
That's clever,
I think that makes a big difference.
especially for visual learners.
Yeah, absolutely. But you mentioned that this thing is a JavaScript HTML5 applet.
Right.
And I'm not a coding whiz.
Me neither.
So can you maybe explain that in slightly simpler terms? What does that even mean?
Please.
Okay, so think of it as like a mini program within the web page.
Okay.
Kind of like a small app on your phone
Right.
that does one very specific task.
Gotcha.
And this applet, it uses languages like JavaScript and HTML5 to make the tank interactive.
So it's the code that actually allows students to, change the tank's size
Exactly.
and then see those reflected in the volume calculations.
Yes, like instantly.
That's really neat.
It's way more engaging, right?
Yeah, for sure. Much more hands-on than just like staring at a static image in a book.
Absolutely. And here's another cool thing.
Okay.
The web page actually gives you the code
Oh, wow.
for embedding the simulator on other websites.
Oh, that's interesting.
So any teacher, or
Right.
really anyone creating educational content, can just grab this interactive tool and incorporate it into their own online resources.
It's like a building block for
Yeah.
more engaging lessons.
Exactly.
Right.
And it's a perfect example of the power of open source.
Oh, absolutely.
Yeah.
And, this whole project really highlights the larger concept of open educational resources.
OER.
Yeah, OER. So essentially, what are those?
Essentially, OER are materials that are free
Okay.
for anyone to use,
Nice.
adapt, for educational purposes.
I like it.
It could be textbooks, lesson plans, simulations like the one we're talking about,
Uh-huh.
all sorts of things.
So it's like a giant collaborative library of learning resources where anyone can access and contribute.
Yeah, precisely. And the fact that this website that we're looking at, the fact that it's based in Singapore,
Yeah.
really shows you the global nature of this movement.
It's cool, right?
Technology is really breaking down geographical barriers,
Uh-huh.
and it's making these high-quality tools accessible to people all over the world.
I love that.
Uh,
Okay, so let's talk about the website itself. Open Educational Resources, Open Source Physics at Singapore.
Catchy.
Very catchy. What else did you find on there that was interesting?
Okay, so one thing that caught my eye was the breadcrumbs navigation at the top of the page.
Yeah.
It's like a trail of digital crumbs leading you back to the source of the information.
Right.
And in this case, it shows us that this page, the simulator page,
Yeah.
is part of a larger section related to something called the ETD at Cradle Conference 2011.
Ooh, interesting.
Now, we don't actually have any details about the conference itself.
Yeah,
Makes you
yeah.
wonder what was going on there, right?
Right. What kind of amazing ideas they were discussing.
Yeah, maybe this volume simulator was like the highlight.
Maybe. Well, even without knowing the specifics,
Right.
those breadcrumbs give us a little sense of the history and context
Well, yes.
surrounding this simulator.
Yeah, for sure. And then further down the page, there's a mention of sample learning goals
Okay.
and a research section.
Interesting.
Although, again, we don't have access to the specific content, but
Yeah.
it does suggest that there's a lot more to this website than just the simulator itself.
So they're not just creating these tools, but they're also studying how they're used
It seems like it.
and what impact they have. That's really impressive.
Exactly. It's a much more holistic approach to education.
I love that.
And then, there are even sections for translations, a video section,
Wow.
and links to other resources.
I love discovering these little rabbit holes of information.
Me too. It's like, what's down there?
Tell me more about those sections.
Okay, well, the translation section, that just points to the global reach of OER, right?
Yeah.
It seems they've made an effort to make this simulator, and probably other resources too, available in multiple languages, so it's accessible to a wider audience.
That's fantastic.
Yeah, and the video and other resources sections, those suggest there's just a whole network of learning materials
Wow.
connected to this website.
Like a treasure trove.
It is. It really is, like all this educational content just waiting to be explored.
Very cool. But hold on, there's one more thing we got to talk about before we disappear down those rabbit holes.
Okay.
Remember that long list in the FAQ section?
The FAQ?
Some of those titles are super intriguing, like antibiotic resistance dice simulation
Oh, what?
and Rocket JavaScript HTML5 applet simulation model.
Wow, the variety is like incredible.
Right. And the creativity. Clearly, this website is a hub for so much more than just physics.
For sure. They're using technology to enhance learning in so many different fields.
I love it. Okay, so we've covered a lot of ground here. We've learned about the volume simulator,
Yeah.
open educational resources in general, and we've kind of gotten a little taste of the amazing work being done by open educational resources, open source physics at Singapore.
It's quite impressive.
But what does it all mean?
Yeah.
What's the big takeaway here for our listeners?
Well, I think one of the key takeaways is the potential impact of open educational resources.
Definitely.
Tools like this volume simulator, they're just one example of how OER can democratize knowledge, make it available to anyone with an internet connection.
It's about empowering learners and educators, right? To access and create these high-quality learning experiences, regardless of their location or resources.
Right, and it highlights the power of collaboration.
Oh, for sure, in the open source community.
Huge.
So this deep dive, it's kind of given us a glimpse into a world where education is no longer confined to traditional classrooms or textbooks.
It's a world where technology makes learning possible, like anytime, anywhere.
That's a powerful thought.
That's from anyone.
And this is just the tip of the iceberg, right?
Oh, totally.
We've only scratched the surface of what open educational resources, open source physics at Singapore has to offer.
I can't wait to see what else we find.
There's so much more to explore on this website, and we're going to continue our journey in part 2.
Stay tuned. Welcome back. In the last part, we were looking at a JavaScript HTML5 applet for teaching volume.
Yeah, that was fun.
And that led to a really interesting conversation about open educational resources, OER.
Totally. Now I'm thinking we should turn our focus to the organization behind this applet. Open Educational Resources, Open Source Physics at Singapore.
Sounds good to me.
Let's dive a little deeper into the impact they've had.
Okay, I'm ready.
One thing that really stood out to me as I was looking through the website was just the sheer number of awards and recognitions they've received. It's like they've won every award under the sun for educational innovation.
It is quite a list, isn't it?
It is. They've been recognized by UNESCO,
Wow.
the Ministry of Education in Singapore, and all these other prestigious organizations.
It's clear that their work is not only groundbreaking, but it's also, highly respected.
Oh, for sure.
Within the educational community.
For example, they received the Ministry of Education Outstanding Innovator Award 2013.
That's huge.
Right. What do you think made them stand out as innovators in education?
Well, I think the award really speaks to their commitment to pushing the boundaries of education and finding creative ways to enhance learning.
Yeah.
It's not about using technology for technology's sake, right?
Right. It's got to have a purpose.
Yeah, they're focused on developing tools that actually address specific learning challenges.
Like that volume simulator.
Exactly. And it's not just awards either.
No.
They're also heavily involved in research projects, like the one titled NRF 2013 EDU001 EL010, Becoming Scientists Through Video Analysis.
That's awesome.
Yeah.
So they're not just creating tools, they're studying their impact.
Yeah, on learning.
Well, I think
That's super important.
I agree. It shows that they're really committed to understanding how their tools are being used,
Yeah.
what effect they have on students, their learning, their engagement.
Right, making sure that their innovations are actually making a difference.
Precisely.
It's a very data-driven approach.
Totally.
which I think is refreshing to see in the field of education.
Agreed.
They're not just assuming that their tools are effective.
Right.
They're putting them to the test.
It's a crucial part of open source development, too.
Oh, how so?
Well, by sharing their research findings, they're contributing to a broader understanding of how technology can be used to enhance learning.
Oh, I see.
So other educators,
right,
researchers, they can all benefit from this work and build upon it.
It's like this cycle of continuous improvement.
Exactly. Speaking of sharing and collaboration, did you notice that the website also mentions some workshops?
Oh, yeah. And training sessions they've done for teachers.
I did. It seems like they're really invested in professional development for educators.
Totally. There's one here, it's called 2001 3 905 TU Area SI Workshop 2 on Java Simulation Design for Teaching and Learning, NRF 2011 EduLab 001.
Wow. That's a mouthful.
It is a bit, but, this focus on training shows their commitment to not just building the tools, but also empowering teachers to use them effectively.
I think that's super important.
Yeah, even the most amazing, innovative tool is only as good as the person using it, right?
Right. So by providing training, they're making sure that teachers have the knowledge and skills to actually integrate these tools into their teaching.
Seamlessly, yeah.
I love that.
It's about building a network, I think, of support for innovation in education.
That's a great point. And speaking of networks, I was also super impressed by the number of collaborations they've fostered.
Oh, yeah. Tell me more.
With other organizations.
Wow.
They've partnered with institutions like the National Institute of Education in Singapore, the Science Center Singapore, even international organizations like UNESCO.
Those partnerships are so valuable.
Right.
They bring together such diverse perspectives, and expertise from all these different sectors. Academia, research, the education field.
Totally.
Yeah.
It's a real testament to open educational resources, open source physics at Singapore's ability to connect with key stakeholders and work together towards this common goal.
It's a beautiful thing.
It is. It's a reminder that large-scale change in education, often requires collaboration.
Definitely.
And a shared vision.
No single organization can do it alone.
Exactly. Now, as impressive as all their work is, I'm a little curious about the people behind it all.
Oh, interesting.
The website doesn't actually give much information about the team members or their backgrounds. We know about Looking and Felix J. Garcia Kalembe, who created the volume simulator.
Right.
But beyond that, it's kind of a mystery.
It's true. It's like they're more focused on highlighting their work.
Yeah, the impact.
Yeah, rather than individual personalities.
What they're saying, it's not about us, it's about the mission.
A humble approach.
It is. But it would be really fascinating to learn more about their stories.
Yeah, their individual stories, the challenges they faced.
What motivates them.
Maybe that's a deep dive for another day.
For sure. But for now, we've gained some really valuable insights into open educational resources, open source physics at Singapore.
Absolutely.
We've seen their dedication to creating these innovative learning tools.
Yes.
Their commitment to research, professional development, and their success in fostering all these collaborations.
And most importantly, we've seen the impact they're having on education.
Locally and indeed globally.
It's inspiring.
It really is. So as we wrap up this part 2 of our little exploration, let's turn our attention to that massive list of links in the FAQ section.
Oh, yeah.
It's like a portal to a vast network of educational resources.
Each with its own story to tell.
All right, you ready for another whirlwind tour?
Let's do it.
Welcome back to our deep dive into the world of open educational resources. We've spent the last 2 parts exploring open educational resources, open source physics at Singapore.
An organization that's clearly dedicated to making learning more engaging and accessible.
Absolutely. And remember that list of links they've got in their FAQ section?
Oh, yeah, the one that was practically overflowing with interesting projects and resources.
That's the one. We're finally diving into that today.
I'm ready. Let's see what treasures we can uncover.
All right. So this list, it's not just a random collection of URLs.
No, not at all.
It's like a carefully curated roadmap to this whole vast network of open educational resources.
Each link is like a little doorway leading to a project, a tool, or some initiative that connects to their mission of making education accessible for everyone.
And there's some seriously captivating titles here. One that really jumped out at me was 2015-6 UNESCO King Hamad bin Isa Al Khalifa Prize for the use of ICTs in education.
Oh, wow. That sounds prestigious.
It is. It's a mouthful to say, but what can you tell us about this prize?
Well, the King Hamad bin Isa Al Khalifa Prize. It's awarded by UNESCO to recognize exceptional projects that are using technology to improve learning, teaching, and educational management.
That's a pretty big deal.
It is. And the fact that open source physics at Singapore is linked to this award, it suggests they were either nominated for it or involved with a project that received this honor.
That's incredible. It speaks volumes about their international recognition.
Absolutely.
And the impact of their work.
For sure.
Okay, get ready for a rapid fire round here because I just have to mention a few more of these titles.
Okay, hit me.
Drawing 3D shapes on an isometric grid.
Okay.
Building the Singapore Young Physicists Tournament, SYPT. Juror assignment web app.
What?
And teacher version. Enhancing primary school literacy with EJS-based word blending interactive tools.
Wow, the variety is amazing.
I know, right? It just blows my mind. And this really just underscores the wide scope of open educational resources.
It's not just about physics or even science. It's about using technology to make learning better across all subjects and for learners of all ages.
I love it. Now, I also noticed some links related to professional development for teachers.
Oh, yeah.
Like 2025-0132, using SLS Authoring Copilot and DeepSeek AI to generate quizzes, enhancing blended learning experiences.
They really seem to be at the forefront of educational innovation, don't they?
They do.
That particular link you just mentioned, that suggests they're looking into how to use artificial intelligence
AI,
to create more engaging and personalized learning for students.
It's really incredible. This whole list feels like a treasure map.
It does, doesn't it?
Leading us to this wealth of resources and inspiration.
Yeah, open educational resources, open source physics at Singapore. They're clearly not just an organization. They're like this a vital part of a global community of people who are really passionate about open education.
Educators, researchers, developers.
That's so cool.
It's a beautiful thing. It's a powerful reminder that knowledge should be accessible to everyone.
I wholeheartedly agree.
And that collaborating and sharing are key to actually achieving that goal.
Couldn't have said it better myself.
Well, we've come to the end of our journey, fellow deep divers. We started with that simple volume simulator, and look where we ended up. This whole vast interconnected world.
It's remarkable, isn't it?
It really is. And along the way, we saw how powerful technology can be in education.
For sure.
How important collaboration is, and the incredible impact that dedicated individuals can have.
It's been an inspiring journey, and I really hope it encourages our listeners to go out and explore the world of open educational resources for themselves.
There's a wealth of knowledge and innovation out there.
Just waiting to be discovered.
So go forth and explore, discover, and learn. You never know what amazing resources you might uncover.
Happy exploring, everyone.